Welcome to this tutorial on debugging Kotlin using IDE debugging tools. Debugging is an essential skill for every developer, and mastering the debugger will make you much more efficient at finding and fixing bugs in your Kotlin code. In this tutorial, you'll learn how to use the powerful debugging features built into IntelliJ IDEA to inspect your code, control execution flow, and quickly identify issues. Let's get started. Before diving into the technical details, let's understand why using a debugger is so important. First, a debugger allows you to inspect the runtime state of your application. This means you can examine variables, objects, and memory in real time as your program executes. Second, you can control the execution flow by pausing your program, stepping through it line by line, and navigating through different parts of your code. Finally, debuggers help you find bugs much faster than traditional print statements. Instead of adding dozens of print statements and rerunning your code repeatedly, you can pause at any point and see exactly what's happening. Breakpoints are the foundation of debugging. They tell the debugger where to pause your program's execution. There are 4 main types of breakpoints you'll use. A line breakpoint is the most common type. You simply click in the gutter next to any line number, and execution will pause at that point. A conditional breakpoint is more advanced. You click on a breakpoint to add conditions that trigger only when a specific expression evaluates to true. An exception breakpoint allows you to break whenever specific exceptions are thrown anywhere in your code. Finally, a method breakpoint pauses execution when entering or exiting a specific function, which is useful for tracking function calls. Let's look at a practical example. Here we have a simple function called calculateDiscount that takes a price parameter and applies a 10% discount. Notice the comment indicating where we should set a breakpoint. By placing a breakpoint on the line where the discount variable is assigned, we can pause execution right at that moment. This allows us to inspect the price parameter, see how the discount is calculated, and verify that the final price is computed correctly. In the main function, we call calculateDiscount with a value of 100.0 and print the result. With the breakpoint set, we can step through this code and watch how the values change. Once your program is paused at a breakpoint, you need to navigate through your code. There are 3 essential stepping commands. Step over, activated by pressing F8, executes the current line and moves to the next line. If the current line contains a function call, step over will execute the entire function without going inside it. Step into, activated by pressing F7, allows you to enter function calls to debug their implementation. This is useful when you need to see what's happening inside a particular function. Step out, activated by pressing Shift plus F8, completes the current function and returns control to the caller. This is helpful when you've stepped into a function but want to quickly return to where it was called from. While debugging, you'll frequently need to inspect the values of variables and expressions. The Variables panel shows all local variables and their current values within the current scope. This panel updates automatically as you step through your code. Watches allow you to track specific expressions or variables throughout the entire execution. You can add any valid Kotlin expression to the watch list, and it will be evaluated continuously. Quick Evaluate lets you quickly check values by hovering over variables in your code. You can also press Alt plus F8 to evaluate any expression in the current context. Finally, Set Value allows you to modify variable values during debugging to test different scenarios without restarting your program. The Evaluate Expression feature is incredibly powerful. By pressing Alt plus F8 while debugging, you can run any Kotlin expression in the current context. For example, you can filter a list of items based on a condition, such as finding all items with a price greater than 50.0. You can create modified copies of objects using the copy function with different property values. You can even call functions and see their return values, or construct strings that include function results. This feature essentially gives you a Kotlin playground that runs within your paused program, making it easy to test hypotheses and explore your code's behavior without modifying the source code. The call stack shows you the sequence of function calls that led to the current point in execution. Reading from top to bottom, you can see how your program got to where it is now. In this example, the current execution is paused inside the calculate discount function, which was called by process order, which was called by handle request, which was called from main. You can click on any frame in the call stack to jump to that location in your code and inspect the variables that were in scope at that point. This is extremely helpful for understanding the flow of your program and tracing back to find where a problem originated. IntelliJ IDEA provides specialized debugging tools for advanced Kotlin features. The coroutine debugger gives you a dedicated panel where you can view all active coroutines and their states. This is essential when working with concurrent code, as it helps you understand what each coroutine is doing and whether any are blocked or suspended. The Flow debugger lets you track Kotlin Flow emissions and transformations in real time. You can see values as they flow through operators like map, filter, and collect. Finally, remote debugging allows you to debug applications running on remote servers or devices. This is particularly useful for debugging production issues or working with Android devices. Let's wrap up with some best practices for effective debugging. First, use strategic breakpoints. Instead of scattering breakpoints everywhere, place them at decision points and state changes where bugs are most likely to occur. Second, clean up your breakpoints when you're done debugging. Leaving old breakpoints in your code can slow down future debugging sessions and cause confusion. Third, use watches wisely. Watches are perfect for tracking complex expressions that change during execution, but too many watches can clutter your debugging interface. Finally, learn the keyboard shortcuts. Mastering shortcuts like F7, F8, and Alt plus F8 will make you significantly faster and more efficient at debugging. With these skills and practices, you're now equipped to debug Kotlin code effectively using IntelliJ IDEA's powerful debugging tools.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.